Alright, so welcome back to the video guys. So in this video we'll start second section of R programming, which is working with R. Now I have divided this section into 6 assignments. So we will slowly build our skills by doing different assignments. So in assignment 1, we will focus on basic arithmetic operations in R. Then in the second assignment, we will do some data manipulation. After that, we will see different loop structures in our third assignment. Loops are essential for any programming language, and hence it is an important topic. We will do this in R Markdown, which is used for creating templates and reports. Then in the fourth assignment, we will use R skills to analyze stock price data and concrete data in assignment 4 and 5 respectively. After that, we will do hypothesis testing in our last 2 assignments, and that is how we will end this section. Now I am assuming you already have installed R, and I am not going to explain it. You can go to their website and do it. It's a pretty simple process. So let's straight jump into our assignment 1. So in this assignment, we will learn basic mathematical operations. Then we'll create vectors. After that, we'll create matrices and perform operations on them like multiplication, etc. And then we'll create data frames. We'll plot histograms and also learn to calculate percentiles, quartiles, etc. So without further ado, let's begin our assignment 1. Okay, so here we are in RStudio to do our first assignment, basic arithmetics. First, I will quickly brief you about the interface of RStudio. So if you go at the top left hand side, you have your toolbar here. You can click on it and then you can view various options available in it. Then as you can see, the screen has been divided into 4 different panels. The top left panel is where you write your code. You can write the code, you can edit it, you can run the code, and you can even save it. Then the bottom left panel is where you will get the results. You can also write the code here, but you cannot save the code here. You can just write it and run it to get your results. The top right panel is where you will find your data. Your variables, your data frame, your matrices that you will create will be displayed here. And the bottom right panel is where you will find help, your graphs will be displayed, etc. So this was just to give an idea about the interface of RStudio. Now let's start with some coding. First we have the basic mathematical operations like addition, subtraction, multiplication, etc. So let's say you want to add 2 numbers 37 and 26. So you can just simply write 37 plus 26 and it will give you the answer. Similarly, if you want to subtract 2 numbers, you can write 37 minus 26 and it will give you the output. For multiplication, you will have to write 37 asterisk 26 and it will give you the output, and so on. Now as you can see, if I mention anything after the hashtag sign, then it will be treated as a plain text and it will be skipped by console while running the code. This is a good way to structure and label your code. Now the question is, how do you run the code? So to run the code, you have a button here. You can just click on it and it will run the entire code. But if you want to run part of it, you can just select that part and press Ctrl plus Enter and you will get the results in the window below. So let's say you want to add these 2 numbers 37 plus 26. So you will select it and then press Ctrl plus Enter. Similarly, you can run the remaining part of the code by selecting it and then pressing Ctrl plus Enter. You can also use the sum function to add the numbers, just like you do in the Excel. You can also take the square of the number like this. You can take the square root of the number like this. You can take the exponential of the number like this. You can take the log of any number like this. Then we can also generate sequence using the seq function. So here we are telling the seq function to generate a sequence between 2 to 7 at an interval of 1. So that is how you use the seq function. You can also achieve the same task by writing 2:7. However, if the interval of the sequence is not 1, then you will have to use seq function. Then you can use the rep command to repeat the values. Here we are repeating the number 3 4 number of times. We can also repeat a sequence like so. There are different possibilities. The idea is that the first argument tells the function that which number needs to be repeated, and the second argument tells the function how many times the number needs to be repeated. Then we can create the vectors. We create vectors by defining the values of the vector under the bracket using C function. Here we have created a variable x, which is a vector with values as 1, 2, 3, 5. You can run it and you can see on the top right hand side the variable is appearing now. If we want to print it, we can just write x and it will be printed. We will create another vector y like so. The values will be 1, 1, 1, 1. Once we create this variable y, it will appear on the top right hand side. Then after creating these two variables, we can perform mathematical operations. If we want to add two variables, we can just write x plus y. If we want to subtract two variables, we can simply write x minus y, and so on. We can also take dot product of these two vectors by using the pipe operators. There are many different pipe operators available in R. You can simply Google it and learn more about it. We will also be using pipe operator as we move along in the course. So to take the dot product, we can write our first variable x, percentage sign, then asterisk, then again percentage sign, then the second variable y. We can run this and it will give us the dot product. You can see the results printed in the bottom panel. Then for finding the minimum or maximum value, we can simply use min function or max function respectively. We can run it and then we'll get the results in the bottommost panel. Now if you want to know the index or the position of the number which is minimum or maximum, then we can use which.min or which.max command. Simply use which.min and give your variable and it will give you the output. Similarly, you can use which.max, give your variable and it will give you the output. So here you can see in the bottom left window the location of the minimum and the maximum values printed. Then we will create a matrix. We will use matrix function to create the matrix. We will store it in a variable called A. Matrix function requires the values of matrix which are given here in the form of vector from 1 to 9. Then in the next argument we will tell the matrix function how many number of rows are required. Here we are saying that we need 3 number of rows. We can run it and it will create a matrix. We can print this matrix by simply typing the name of the matrix and the matrix will be printed in the bottom left window. We can see here that the values of the vector that we had given to our matrix function are filled column wise here. We can also return a particular element of a matrix like so. Simply type the matrix that we have created, that is A, and then write the row and column number within the square brackets. Here it is first row and second column. So it will return the element which is at the intersection of first row and second column. We can also perform mathematical operations on matrix. We can divide or multiply the matrix with a scalar quantity by simply writing it as A asterisk 3 for multiplication and A slash 3 for division. To transpose the matrix, simply write T and the matrix name within the brackets. It will transpose the matrix. We can run it and we can print the transposed matrix in the bottom left window. Now the next part is to create the data frames. Recall a data frame is just like a matrix, but it can contain variables of different classes. So first we will create 3 different variables, x1, x2 and x3. So as you can see here, x1 will contain characters and x2 and x3 will contain numbers. So we will create these 3 variables. After creating these 3 variables, we can use data.frame function to create a data frame. We can run it and our data frame is created now. We can use row names and call names function to name the rows and columns of our data frame. Simply write row names, then your data frame, then assign a name vector to it. Similarly, write call names, then your data frame and assign a name vector to it. We can run this and we can print it in the bottom left window. We can see that we have assigned the row and column names to our data frame. Now let's generate few random variables. rnorm can be used to create standard normal numbers, numbers that follow normal distribution. Here rnorm 500 will generate 500 numbers that follow normal distribution. We can create these numbers and store it in a variable called x. Now to check if they are normally distributed, we can check mean and standard deviation using the mean and SD function. We know that for a standard normal distribution, the mean and standard deviation will be 0 and 1 respectively. So here you can see it is almost 0 and 1, which means the number that we had created follow the standard normal distribution. Now to create a histogram for these numbers, you can simply use HIST function for a basic histogram. We can also define other arguments to customize our histogram, but for now we will create a basic histogram. We can see in the bottom right window the histogram is displayed and it follows the normal distribution. We can also create normally distributed numbers with a mean and standard deviation of our choice. We can simply write rnorm, mention how many numbers we need to generate, and then mention mean and standard deviation as shown here. We can run this and it will create 25 normally distributed numbers with a mean of 5 and standard deviation of 25. Now let's understand three important functions: dnorm, pnorm, and qnorm. First we have dnorm. Dnorm returns the value of probability density function. Recall the probability density function. Dnorm will return the value for a particular quantile x of the probability density function. We have three arguments for the dnorm function. The first argument is the quantile, the second one is mean, and third one is standard deviation. So here our quantile is 2, mean is 0, and standard deviation is 1. We can run this to get our results. Then we have pnorm. Pnorm calculates the probability of being less than or equal to a given quantile. Let's see this with an example. Let's say we have a group of students and we have their score. Here mean is 72 and standard deviation is equal to 15. Now we wish to find the probability of percentage of students scoring less than or equal to 80. In other words, the area towards the left side of the normal curve. Here we can simply use pnorm. The arguments will be 80, 72 and 15, which are quantile, mean and standard deviation respectively. We will run this and we will get our results as 0.7. So 0.7 is the probability of being less than or equal to 80. Or you can say that 70% of the students have scored less than or equal to 80. In other words, we can say that the value at 70th quantile is 80. So that's how we use pnorm. The last function is qnorm. Qnorm is just the inverse of pnorm. It calculates the value at the particular quantile given the probability p. Let's take the above example again. We previously found out that probability p is equal to 0.7. Mean we already know it is 70 and standard deviation is 15. So here we are giving the quantile, which is 70%, as an input, and it will return the value at that particular quantile. We can run this and we can see the output is 80, which was the score given in the previous question. This also means that 70% have scored less than or equal to 80. So that is how you use qnorm function. So this was all from this video. We have covered few basic mathematical operations in this video. Now I'll catch you up in the next video where we'll talk about basic data manipulation in R. Until then, have a great time. See you.